Bismillahirrahmanirrahim. We are still speaking about the flux of a vector function through a given surface. And we define the flux to be the double integral or surface integral of the vector function. The flux is given by f dot n ds. And in this example, we need to find the flux of the given function xi plus yj plus zk out of the unit cube, where x, y, and z are between 0 and 1. Now to find the flux, I think out of the unit cube, we have to find the flux going out of every face. For the cube, we have 6 faces here. So this is, I need to find the flux going through the first face, second, third, fourth, up, down, and to the left. So we have 6 faces for the cube. So to find the flux, we have to find the flux for each one. So I would say this is S1 plus the flux going through S2 plus the flux going the third one, fourth, fifth plus the flux going through the sixth phase. And in that case, we are going to deal with these phases individually and find the normal vector for each one of them. And to make this clear, let's think about the two-dimensional case. So for that, we are speaking about the unit square. 0, 1, 1, and this is 1, 1. For the unit square, let me call this is S1, the first side, S2, S3, and S4. For each one of these sides, we have equation or function that represent that side. So for S1, let me start with the, okay, S0. We have S1 and S2. S1, that gives me the equation is x equal to 1. The equation for this side is s equal to 1. It's constant with respect to x, but y is changing. So the equation for this one is x equal to 1. For S2, x equal to 0. Think about these two sides, which correspond to the first face and the second face in the cube. Now for the normal vector, that normal getting out from this one. This is n. We call it n1. So it is in the positive direction. We need to find the unit vector in the positive x direction. And that one is equal to I. This is normal to the first side, S1. The normal unit vector will be I. For S2, now we will go in the negative x direction. If this is y, this is x. So the normal vector in that case, let me call it N2, equal to minus I. For the next one, S3, this one, we have the equation for that one is y equal to 0. And the normal vector will be down because it is out. We are finding the flux out of the square or out of the cube. And in that case, N3 equal to minus J. For S4, Y equal to 1. And N4 will be up, going up. That will be plus J. So these are the four sides for the unit square. If we are speaking about the unit cube, we have to add the Z. So in that case, we'll have S5 and S6. So S5 when Z equal to 0, that is the floor of the cube, and the normal vector in that case will go down, which is minus K. And 6, 1 when Z equal to 1, and in that case, the normal vector would be plus K. So taking into consideration that f is given by x, y, z. Let's find the first flux now. S1 is f dot n ds, which is equal to integration of s that will be x, y, z dot 1, 0, 0 ds. That will be x ds. And integration in this case, since we are dealing with the x direction, so the r will be on the z, y, or in the zy plane. So for S1, this is in the R will be in Z or YZ plane. Which means we are going to find S. The value of X in the first phase, it was 1. So it will be 1. ds will be written as dy dx, which is equal to and the limit between 0, 1 for y and sorry, not dx, this is dz, and 0, 1 to y, which is equal to 1. For the second phase, number 2, S2, where x equal to 0 in the second phase. We'll have minus x ds. But x equal to 0, it will be 0. For the third one, when y equal to 0, y z multiplied by, or that product with 1, 0, minus 1 and 0. Ds, which is equal to minus y ds. But y equal to 0, so this is equal to 0. Number 4 is 4, and this is when y equal to 1. I will have y ds equal to y equal to 1, and ds will be this one. Now since we are dealing with the y, so ds is equal to dx dz, and the limit would be between 0, 1 and 0, 1, and this will be also equal to 1. Number 5, when z equal to 0, that will be the fifth one. Normal vector is 0, 0, minus 1 ds. Minus z ds, but z is equal to 0. So I will have 0 in this case. Number 6, the integration of the sixth phase, that will be z d s, or that is when equal to 1, the integration of s sub 6, or the sixth one will give me plus z ds equal to the integration z equal to 1, so this is 1 ds over r. That will be dx dy, and the limit for x from 0 to 1, for y from 0 to 1, and this will give me 1. So the total flux will be equal to, for each one of these faces, I have 1 and 0. So the total will be 1 plus 0 plus 1 plus 0 plus 1 plus 0, and the total flux will be equal to 3. So the flux of the given vector function x, y, z, getting out the unit cube is equal to 3. So the idea is just to find the unit normal, or normal unit vector for each face, and then integrate, or just apply the surface integral to find the flux for each one, then find the total for all of these values. And that will give me the total flux getting out the unit cube.